All right, we're back. We're going to be on page 9 of notes 15 of Calc AB, but I thought it'd be helpful. I need more space to kind of like write out what I'm going to write. So I added in a page. It's actually graph paper, which is nuts because I kind of hate graph paper. But this is our essential setup here. So we have a function. This is straight continuation, right? We have a function, our bounding function we're now saying is f prime of x. We're saying that f prime of x is continuous on the interval from a to b. Because f prime of x is continuous, we know that f of x, the function that this is the derivative of, is also continuous. And we know that that function is differentiable because its derivative, f prime, exists everywhere between a and b. So that's kind of where we are. So what we're trying to do is we're trying to find the integral from a to b of f prime of x dx. That's like our goal, right? So we want the integral from a to b of f prime of x dx. That's what we're trying to figure out. Okay, so we've said that the mean value theorem applies to f of x on the interval from a to b because f prime exists, so f is differentiable. If f is differentiable, it's continuous. So mean value theorem applies to f of x, right? That's a big deal. So what we're going to do is we're going to do the usual thing, cut this up. So I'm going to say like this is delta x, right? And then this will be x1, x2, x3. So you should really do this with like an infinite number, but like who has time for that? So we're just going to do it with this number and kind of see how it works. So these are all delta x's. I'm going to do a copy paste situation here. Copy. What? Paste. Why can't I paste you? Paste. Paste. Every one of these is going to be delta x. It's like sometimes it lets me paste and other times it asks me if I want to change the style of something. What? I don't know. So we made even cuts, right? So all of them are delta x's. So for example, then, that means that, like, of note, x1 minus a is delta x, and x2 minus x1 is delta x. x3 minus x4, what am I always doing here? Oh, it's bigger, x3 minus x2 is delta x, dot, dot, dot. And then finally, b minus x6 is also delta x. Like all of those are equal to delta x because they're all equally spaced out. It's going to be kind of important. Okay, so we want to make our rectangles. We're going to choose our rectangles, the heights of our rectangles, in kind of a weird way. We know that MVT applies to f of x. So MVT applies to f of x, right? So since MVT applies to f of x, we know that there's f prime of some c1 is going to be f of x1 minus f of a, f of a over x1 minus a, right? So mean value theorem applies to f of x, which means we can apply the mean value theorem on this interval. So there's some c1 that's an element of x1 to a to x1, right? Because that's the order it should go in, such that f prime of c1 equals this. We're going to put the height at c1. So let's say, I'm just going to make it up. Let's say that this is c1, right? So what we'll do is we go up. And then what's the best way to do this? I'm trying to work this out on my own here. Duplicate there, and then duplicate here. And then these aren't the right height. Okay, and then if I go across, so I think it's better if I like take some time to make sure this like works. Okay, so that's our first rectangle. Our first rectangle has an area of f prime of c1 times delta x. And then we're going to keep doing this. So on the interval, we can say that there's like f prime of c2 will be f of x2 minus f of x1 over x2 minus x1, right? So I'm going to choose to put the height of this rectangle at C2. So I'm going to say that C2 is, let's say C2 is like here. Wrong color. Let's say C2 is here. And then I'm going to do it again. Try to be careful. It's like copying and pasting should make this easier, and it probably would if I was better at that kind of thing. There, duplicate, and I think, I don't know, it claims it did it. There, I mean, that looks pretty good. Okay, so we put our height there. So the area of this rectangle is f prime of C2 times delta x. And then we're going to keep doing that. So should I keep doing that and make you watch? Should I keep writing them down? I don't know. Let's see how fast I can do it. I mean, it's not going to be fast. So this feels like a good opportunity for you to fast forward if you're into that kind of thing. So I'm just making them up where I think I should put them. So feel free to make up yours wherever you want to put them too. I'm not being super careful about it. I'll go back and like finish and like do it right. Well, I don't know about do it right, but I'll like put in the C values at some point. Go vertical. I don't know if that did or not. It does, like, it wants to snap to things, and sometimes that messes things up like a lot. Get there. Okay. And then see, like here, this is going to be a nightmare. Well, that was not a nightmare, but it could have been. All right, we got a couple more to go. I apologize how boring this is. I'm going to say it's like here, just to be extreme. Be vertical. I mean, that's definitely not vertical. So what do you do? What does one do? Oh, maybe if I start up here and then I don't know. I'm going to use that though. Duplicate, and then straight across. See, like no chance that worked. Gosh, why? Let me duplicate you, then be the right height. That's supposed to be the right height. I don't know. It just wasn't. And like this, I'm spending way too much time on this part for anyone's liking. So let's just, I mean, I can't speed up, so it doesn't really matter. I'm like, let's just do it faster, but I can't. So whatever, people. Duplicate. Be the same. Why can't you be the same height as that? Ah, God, I hate this so much. Okay, you know what? Here we go. Just whatever it looks like, it looks like. Throw caution to the wind at the end. There-ish. And then finally, let's just do whatever. There. I will duplicate. This doesn't look good, and I hate it, but that's fine. And then we're going across. Okay, so God, that took forever, and it looks like crap. But what are you gonna do? Complain, probably. So like here is C3. Here is C4. C5, for whatever reason, is like way over here. C6 is like here. Am I off? Oh no, it's like always the one before. Okay, and then C7 is apparently, I don't know, like there. So what are our areas? F prime of C3, delta x. F prime of C4, delta x. F prime of C5, delta x. We're like actually almost done. There's like a couple of things we got to do. I'm saying that like stick with me, or don't. I mean, like, this is kind of the proof. I don't know how much you need of the proof. Okay, so now we're saying if we could do an infinite number of these, right? So an infinite number of these, we would say that the integral, if infinite number, we would have the integral from a to b of f prime of x dx is equal to the limit as n approaches infinity of, so we just have like f prime of c1 delta x plus f prime of c2 delta x plus dot 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 plus, let's say, f prime of cn. Should I do cn minus 1? All right, I'll do it, but I'm probably gonna mess that up. Plus f prime of cn delta x, right? We want the limit as n approaches infinity of that. Okay. Now, what is going to happen here? Well, what's going to happen is I'm going to replace f prime of c1 with this, f of x1 minus f of a over x1 minus a. And I'm going to replace all of them with that. So this is the limit as n approaches infinity of, so f prime of c1, this feels like a job for a highlighter. F prime of c1 is about to become this. F prime of c2 is about to become this. And correspondingly, all of them are about to become that. So instead, we'll have f of x1 minus f of a over x1 minus a times delta x plus f of x2 minus f of x1 over x2 minus x1 times delta x dot dot dot. Okay, now I gotta like figure out what's happening here. So f prime of cn minus 1 is what? That's why I didn't want to do it. Okay, so it's always like this and this match up, and then this is one less. Okay, so it's going to be f of cn minus 2 minus f of cn minus 1 over cn minus 2. Nope, yes. No, it's x, it's not c. I got this. Do I have this? I hope I have this. I think I have this. Delta x plus, is this going to be worth it? Kind of. F of xn, because it's the same, minus f of xn minus 1 over xn minus 1 times delta x. Whew. Okay. All right, we're getting somewhere. The next thing to remember, if you remember anything, is that all of these are just delta x's, which means that this is a delta x, a delta x, a delta x, a delta x, which means they all actually just cancel with these, and we're just left with these numerators. So we're getting there. So this is going to be the limit as n approaches infinity of, so it's f of x1 minus f of a plus f of x2 minus f of x1. Now, I'm going to write one more just like that. It'll be plus f of x3 minus f of x2 plus dot 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 plus f of xn minus 2 minus f of xn minus 1. Uh-oh. xn minus 1, n minus 3, n minus, this was supposed to be n, God, I hate this. This was supposed to be n minus 1 and n minus 2. n minus 1, n minus 2, n minus 1, n minus 2. Yes, okay. Is anybody even watching this? Probably not. n minus 2 minus plus f of x. Come on. N minus f of x, n minus 1. I gotta move this like way over. I don't know. Why am I cramming it all? Oh my God, I can't even do it. Like, why did I cram everything in here when I had so much space? I mean, geez, what even? Okay, x, n minus 1. Okay, whew. God, people. What do we got here? We got some stuff. Well, look, you have fx1 minus fx1, fx2 minus fx2. In fact, this will cancel. Then you have fxn minus 1 minus that. This will have canceled because somewhere in here there's that. The only things that don't cancel are, I swear to God, we're like basically done. This and this. Those are the only things that don't cancel. But what is x sub n? X sub n is actually b. So this whole thing has simplified down to negative f of a plus f of b. Or we could say, if you remember, this, the integral from a to b, this is a big deal. But it's like, it's a big deal. This must be what like finishing an ultra marathon is like. It's like, yeah, that's exciting, but God, that was a lot. F of a, holy cow. All right, this is called the fundamental theorem of calculus. And everything about the proof makes a lot of sense, but is like so annoying. This is FTC, fundamental theorem of calculus. Oh man. Okay, so I don't really have anything else to say about it. If this is f prime, if we can figure out what f of x is, then we just do f of b minus f of a. That's it. It's amazing. This whole page has all that typed up, so I could have just like walked through it, but I thought it was better to handwrite it. I regret that in so many ways at this point. But anyway, we're done with this page. I will be back in the next page to use the fundamental theorem. It's a really big deal. Obviously, it's called fundamental. So I will see you there.